so now we're gonna take these 3D figures and we're gonna cut a slice out of it. And you have to, they'll ask you, what is the area of the cross section? If you take a cross section of a sphere, either parallel or perpendicular to the any of the 3D figures, either parallel or perpendicular to the base. Now, a sphere is exactly the same all the way around. So your cross section, the shape of your cross section does not change, regardless of wherever you do that cross section. Okay. Anywhere you slice a sphere, the shape of your cross section is going to be a circle. Okay. And so it'll ask you, what is the area of the cross section of a sphere parallel to the base? And so you have to know the area, that the cross section, the shape is a circle. If I say describe the cross section of a sphere, you'll say circle. Okay. Now if we're talking about cylinders, that shape does change if you're parallel to the base or perpendicular to the base. If you have a cylinder and you slice it I can't say horizontal because if it's turned on its side, parallel to the base would be up and down, right? So if I slice it parallel to the base, then that cross section is a circle. But if I slice it perpendicular to the base, then that cross section is a rectangle. Y'all see that? So it depends if it's parallel to the base or perpendicular to the base. And you have to pay attention to that no matter how the shape is turned. Okay? Basically, if the cross section is going through the top and bottom base, it's going to make a rectangle. Okay? And if it's going through the center, it's going to make a circle. Now, a cone. If you slice a cone parallel to the base, it's going to make a circle. Okay? But if you slice it through the top, through the pointy part on top, it's going to form a triangle. That cross section is going to form a triangle. It's like if I slice it in half like this, what face do I see? I'll see a triangle. Okay? Okay, everybody understand this? So if I say, find the area of the cross section if it's parallel to the base. So you can find the area of that circle. You need to know the radius of that cone, you find the area of the circle. Or if I said perpendicular to the base, you find the area of that triangle. Okay? Okay, if it's a rectangular prism, it doesn't matter how you slice it, parallel or perpendicular, it's going to create another rectangle. Okay? So, it's either a square or a rectangle. If it's a cube, if you slice it, your shape is going to be a square, right? But if it's a rectangle, your shape is going to be a rectangle. All right? Now, if it's a pyramid with a square base, because we have a triangular prism and a rectangular, and then we have a pyramid with a triangle on the bottom, and then we have one with a rectangle on the bottom. If it's got a rectangle on the bottom, if you slice it parallel to the base, it's going to create another rectangle. But if you go through the top, it's going to create a triangle, just like the cone. Makes sense? Okay, so I'm going to work a couple of examples for you. So it says, given a sphere with a volume of 64 cubic centimeters. So first thing I do whenever I see this, I'm gonna draw that figure to the best of my abilities. And I know that the volume is 64 cubic centimeters. Find the area of the perpendicular cross section. Now, it doesn't matter how I slice this sphere, the area is of that cross section. What's the shape of the cross section? A circle, right? Doesn't matter how I do it. So it's gonna be another circle. The only thing I need to find that area of that circle is the radius. Now, they gave us the ability, they didn't give us the radius, but they have to give you a way to find it. And so, volume equals 64 cubic centimeters. that is my way to find the radius. So you have to find the radius first, and then go back and plug it in and find the area of that circle, okay? And so we use the volume. So the volume of a sphere is 4/3 pi r cubed. Okay? And so we know the volume, we don't know the radius. So we plug in the volumes, that's 64 equals 4/3 pi r to the third power. And now we have to solve for r. So we have to get rid of everything else that's multiplied to it. So I'm going to divide both sides by 4/3 pi. Okay? So I'm going to divide both sides by 4/3 pi. And that's going to get rid of that. And that'll just leave me with r to the third power equals whatever that calculates to, right? And then to solve for r, what do you have to do? Cube root of both sides, correct? You're going to take the cube root of both sides. Well, for these purposes, if you have to find the radius first, or if you have to find a missing piece of information first, calculate it and round it to the nearest hundredth. And then use that to plug it in to the next. Remember when we did the area, we had to find all the little pieces of those triangles first? Okay? So round intermediate values to the nearest hundredth, and then plug them in. And that way we can all be on the same page and get the same answer. Okay? Okay, and so we take the cube root of both sides. So r is approximately equal to 2.48. All right? And so now we have what we need to find the area of that circle. The area of the circle is pi r squared. So that's pi times 2.48 squared, which is 19.34. What is my unit? Centimeters squared. If you're finding area, it's square units. If you're finding volume, it's cubic units. Okay? Any questions? Okay, so this one says, given a cylinder. So first thing I'm going to do is I'm going to draw a cylinder. Cylinder with a radius of 4. So that's 4. And a height of 18. So that's 18. Find the area of a cross section parallel to its base. So parallel to the base forms a what? A circle. Parallel to the base is here. Okay? If it was perpendicular to the base, that would be a rectangle. Okay? So we're finding that we need to find the area of that circle. Well, the area of the circle, the radius is still the same for both of them. Okay? And so, so area is pi r squared. So area is pi times 4 squared. So area is 50.27 square inches. Yes. Oh, sure. Okay. Next it says, then find the area of the rectangle formed by a cross-section perpendicular to the base. That's why they gave us 18. Because we're using the same cylinder. And so our same cylinder, the height was 18, the radius is 4. They want you to find, now this one, they're nice enough to tell you that the cross-section perpendicular to it forms a rectangle. And to find the area of a rectangle, it's length times width, correct? So area equals length times width. Well, the length we'll say is 18. What's the width? 8. It's the diameter of the whole thing. So 18 times 8. So area is 144 square inches. Any questions? Everybody's good? Okay. Given a cone. So I'm going to draw a cone. with a radius of 7 feet, so this is 7, and a height of 4 feet, so that's 4. Find the area of the triangle formed by a perpendicular cross-section through its center. So if I was slicing it parallel, that cross-section would be what? A circle. But I'm slicing it perpendicular, so that cross-section is what? A triangle, and it looks like this. Okay? And so the area of the triangle, what's the formula for area of a triangle? 1/2 base times height. So that's 1/2. The base is what? 14. And the height is 4. So sometimes they'll give you this slant height, and you'll have to go find the height. Okay, so you have to be careful. And so once you calculate that, you get 28 square feet. Any questions? All right. Given a cube, now, cube. Given a cube with volume 1728 cubic centimeters. Find the area of a cross-section parallel to the base. What's the shape of a cross-section parallel to the base? A square, right? It's a square. In order to find the area of a square, we have to multiply length times width, right? So how do we find the length and width? You just take the cube root. Because the volume of a cube is the length, the width, and the height are all the same, correct? So I say 1728 equals x to the third power. Because it's x times x times x. They're all the same. And so you take the cube root of both sides, and you get that the length of each side is 12. So the area is 12 times 12, which is 144 centimeters squared. You have to make sure that you get the unit correct. Any questions? So everybody good with cross sections? Okay. Next is a rotation. Next is a rotation. So you take a 2D figure and you rotate it, and it's going to form a 3D shape. If you take a triangle and rotate it, it forms a cone. Now, when you're rotating a cone, you're going to be rotating it around the center. You're going to be rotating it around the center. Okay? Cones will always be rotated around the center. And so if you spin that triangle, it's going to make a cone. Okay? However, a rectangle, when you rotate it, it forms a cylinder. It always forms a cylinder. But it can be rotated either around the center, or it can be rotated on an edge. Okay? They're both going to form a cylinder, but if it's rotated around the edge, it's going to make a much bigger cylinder. See what I'm saying? Like if I took this and I rotated it around the center, it's just going to make a cylinder this wide from here to here. See what I'm saying? But if I rotate it around here, it's going to make a much bigger cylinder. The width of the cylinder will be twice the length of this paper. In other words, if I rotate it around the center, the radius of the cylinder is from the center to the edge, right? So this is an 8 by 11 sheet of paper. If I rotated this, my radius would be 4. If I rotated around the center. But if I rotated around the edge, my radius is what? 8. Okay? If they don't tell you where it's rotated, you are to assume that it's rotated around the center. If they don't specify, then you're to assume it's rotating around the center. Because if it's a rectangle, it's different. You know, that value changes. So if they don't say, it's just around the center. All right? And any circle rotated forms a sphere. and they're rotated around the center also. Okay, so it's really only the rectangles that you have to be careful with where it's rotated, because that changes the dimensions of the cylinder. All right. So let's look at a problem that talks about this. It says, an isosceles triangle. What's isosceles mean? Okay, two sides are the same. An isosceles triangle base is 10 feet. So we know those two are the same. And has an altitude of 22. So that means the height of that triangle is 22, correct? Now, if it's isosceles, we know these two values are the same, right? What else do we know about that base? It bisects it, right? If it's isosceles, remember isosceles triangles bisects the base. So that means this is 5 and this is 5. That means these are the same because it's isosceles, specifically because it's isosceles. And then it says, what is the volume of the cone made by rotating this triangle? And so, now this one, they tell you that it's going to form a cone. So volume of a cone is 1/3 base times height. 1/3, area of the base times the height. So if you have a cone, the base is a circle, right? And so you need to know that radius. They told you it was isosceles so that you would know what this radius. What is the radius? 5. The radius is 5. And so volume equals 1/3 times pi times 5, pi r squared. Okay? And then times the height of the cone, which is 22. And when you calculate that, you get 575.96 cubic feet. Okay? See, this one didn't say rotated around the center, but you're to assume it's rotated around the center. Okay? Alright, so it's going to form a cylinder with a radius of 2. Okay, it didn't say where to rotate it, so you're to assume that you rotate it around the center. And so if you spin that rectangle around, it's going to make a cylinder with a radius of 2. So the volume of a cylinder is area of the base times the height. Well, the base for a cylinder is a circle. So it's pi r squared times the height. So it's pi times 2 squared times 9, and that gives you 113.10 cubic feet. How'd y'all do? Good? Alright. We're not going to do this one. I believe y'all can do example 7, no problem. You're going to have some practice in a minute. But let's look at, we're not going to do number 1 either. Well, I don't even have to calculate it. The perimeter of a square patio is 24 yards. How long is each side? 6. Okay. Now, let's look at this one. So these are modeling with geometry problems. So they just give you it's just a regular geometry word problem using this stuff that we've learned. It says, a student makes a model planet with half of a styrofoam ball of diameter 10 inches. So half of a styrofoam ball is half of a what? A sphere. So here is there's half of our sphere, right? And we know it has a diameter of 10 inches. So, alright. Which sits cut side down, now I need to draw it down, I don't think I did the problem. Which sits cut side down in the center of a flat cardboard disc. So that's also the shape of a circle. So you got a styrofoam ball sitting on a disc, a cardboard disc. And it says in the center of a flat cardboard disc of diameter 100 inches. So from here to here, that's 100 inches. The disc is a lot bigger than the circle. It's like a science project. What is the area of the disc that is left uncovered? So what do? Find the area of both and subtract. The larger one minus the smaller one. When you subtract out the area of a piece, it's like cutting that out and throwing it away. Okay? So they want the area of that. So you have to do the area of the larger minus the area of the smaller. So and they're both circles. So the larger circle, the diameter is 10, so the radius, the diameter is 100, so the radius is 50. And for this one, the radius is 5. So you say pi, the larger one, times 50 squared. Minus pi times 5 squared. Now, it doesn't say what is your answer in terms of pi. It'll say, so we're going to give an exact value round to the nearest hundred. Okay? And so, but I'm going to show you, I do want you to find it in terms of pi first and then calculate it. So that way you have both answers. All right? And so this is 2,500 pi minus 25 pi. And when you combine those, you get 2475 pi. So if they wanted an exact answer, you'd stop there. That would be the answer. But that is approximately equal to 7775.44 square inches.